Hey, fourth graders. I wanted to introduce you to our topic for this week for math. So this is just kind of new for me, creating a recorded lesson. So just kind of bear with me as I do this. So we've been comparing unit fractions. Just as a reminder, a unit fraction is anything that has a 1 in the numerator. Okay, so 1/2 or 1/3. Any of those are what we call unit fractions, okay? So what we're gonna start looking at, and we were comparing them, so we're saying which one was bigger, 1/2 or 1/3. And we talked a lot about how the bigger the denominator is, the smaller the pieces are. And so we could have seen that if we created fraction bars that are the same size that show the two different fractions given. So for example, this is, sorry, gotta get back in the habit of writing on a whiteboard. This is 1/2, and then down here we've got thirds. So this 1/2 is a lot bigger than this 1/3 piece. Okay, so that means that 1/2 is greater than 1/3. Now reminder, when we're comparing fractions, we're using the greater than, the less than, or the equal to symbol to show which one is greater than, okay? So that's just something to remember as we are doing these comparing fractions. And I will keep those up here, greater than, less than, or equal to. Those are our three options when comparing fractions. So non-unit fraction, like I said, is anything that is not, does not have a numerator on the, of 1, okay? So the first thing that we're gonna look at is different denominators but same numerator. Because with the unit fractions, it was always the bigger the denominator, the smaller the pieces are. So the one with the smaller number on its denominator was always the bigger fraction. But that's not the case whenever we have different denominators. Okay, so in the same numerator. So that this kind of is important for us to realize. So let's, for example, say we have 2/3. They want us to compare it to 2/5. Okay, so yes, we have the same amount of pieces given. So we have 2 in the numerator, meaning that we have 2 pieces of each of the candy bars, but the size of the pieces are different. So I'm just gonna draw a visual to kind of show that to begin with. So for example, let's do fraction bar here, make the fraction bar the same size. This first piece, according to our fraction over here, 2/3, that 3 tells us how many pieces we have, how many pieces the whole is split into. So that means it's in thirds. That's our first piece, and we have 2 of them. Okay, then our second piece is that fifths. Now it's kind of tricky to cut something into fifths and do it evenly, so I'm just gonna do my best. Pretty good, okay? So then I have 2 of those. 1, 2. So the biggest thing here is we're always trying to find which one is the bigger one in our comparison, and then we'll match the symbol to what we need to put in our equation. So according to this, 2/3, well, our 1/3 pieces are bigger than our 1/5 pieces, and we have 2 of them. So having 2/3 is a lot greater than having 2/5 because the fifths are smaller pieces, okay? So in this case, we would say that 2/3 is greater than 2/5, okay? So different denominators, same numerator. So even though the numerator is the same, that doesn't automatically mean that they are equal. That's what I want you to know here. Just because the numerator has the same number as the one you're comparing it to does not mean that it's greater, or does not mean that it's equal to each other. Okay, so let's do another example. it out a different color here. That way we can see a little bit better. Let's use blue. Okay. So let's think of another one we could do, let's say with the same numerator. So for example, we could have 3/4 compared to, that circle represents the missing symbol of greater than, less than, or equal to. 3/4 compared to, let's say, 3/6. Okay, so again, our numerators are the same, but the denominators are different. So it's going to be really important for you to know that just because the numerators are the same, it's not an automatic they're equal to each other. You have to pay attention to the denominator. So I'm going to draw my fraction bars. Make sure your fraction bars are equal to each other because we want to compare them equally. They have to have the same size whole. Okay, so 4ths, and then 6ths, and then I've got 3/4, 1, 2, 3, and I've got 3/6, 1, 2, 3. Now, clearly looking at this, you can see that the 3/4, 1, 2, 3, 4, 3 out of the 4 given pieces is a lot bigger than the 3/6. So therefore 3/4 is greater than 3/6. Okay, I'm going to give you a problem. I want you to do it on your own. I'm going to give you the problem. I want you to pause the lesson, and then I want you to check and see if you got it right. Okay. Let's do 2 6 compared to 2/3. Let's go ahead and pause it, and then see if you get the answer right. Maybe a second to pause it. Okay, so what you should have done is, if you can kind of tell this without drawing it, then I'm perfectly okay with that. The way you would know is that, well, the 6 pieces are smaller because there's more of them. If you still need to draw it to see the visual of which one is bigger, then that's perfectly okay too. Oops. My drawing skills are off. It's been a while since I've had to draw fraction bars. Okay, so 2/6, then 2/3. Ooh, yeah, see, that was way off. We all know my drawing skills aren't great. There we go. Okay, so 2/6, 1, 2, compared to 2/3. 2/3 is a lot larger than this. So that means 2/6 is less than 2/3. Okay, remember, I know we don't like to say it this way, but it opens towards the bigger fraction. Okay, so that's different denominator with the same numerator. What you could also see is having the same denominator but a different numerator. So for example, let's look. So same denom, different numerator. Okay, so for example, we could do 2/5 compared to 3/5. So as you can see in this one, we've got the 5ths is the same numerator as, or same denominator as each other. Okay, so this kind of makes it a little bit easier because now we have fraction bars that are split into the same amount. And I find this one a little bit easier because, well, if the denominator is the same, okay, so the pieces of the sizes, or the size of the pieces aren't changing, but you can tell which one's bigger because if you have 2/5 of a candy bar compared to 3/5 of a candy bar, you'd probably want to eat 3/5 of the candy bar because you'd get more candy. So that's what this looks like whenever you draw it. So we've got the same size pieces. So on this one, I've got 2 pieces compared to 3. Okay, so 2/5 is less than 3/5. By the way, my secret word is chicken. Okay. So same denominator, different numerators. The biggest kicker with that is the denominator, the pieces are the same size. So if you have a bigger number in the numerator on one of them than the other, chances are that's the bigger fraction. Okay. Let's try another example. Another example we could use, switch up my color here, is, could do like 3/8 compared to 5/8. So I want you to take that one, 3/8 and 5/8. I want you to go ahead, pause the video, and try and get this one. When you're done, unpause. Let's see if you can get it right. Say which one is bigger then. Okay. All right. So you just unpause the video. So one way that I could do this is create fraction bars that are split into 8s. That means that our whole is split into 8 pieces. And just a quick tip, when splitting the fraction bar, since 8s is an even number, what you would do is just keep splitting your fraction bar in half. So in half, now I have 4ths, then split each of those in half, and now you have 8s. Just a quick tip. Okay. And it's okay if your pieces aren't super accurate, super the same size. Okay, so for this one I have 3/8 here, and then I have 5/8. So because we had more 8ths, more 1/8 pieces, because remember each of these represents 1/8 of the whole. And altogether we would have 8/8, which I hope we all know at this point equals 1, or 1 whole. Okay, so having all of those together, 8/8 is the same thing as 1 whole. So in this case, I have only 3 1/8 pieces. I have 5 1/8 pieces here. I have more 8s if I have 5/8. So therefore 3/8 is less than 5/8. Okay. So what you're going to do next is I'm going to give you a few problems to work on in a Google form. You will be showing me that you understand what was taught today. I know it was a short lesson. We're trying not to make them super long. If you have questions, my Zoom office hours are Monday, Wednesday, Friday, 9 to 9:30 a.m., 3 to 3:30 p.m. I have only heard from a couple of you, so I would really love if some of you logged on and were able to ask me questions or just kind of chat with me, because I miss you guys, okay? So please let me know if you have questions. You will have an exit ticket to do after you watch this lesson, to just show me your understanding, okay? See ya.